Hi, I'm Sam, and I will be talking about creative coding. So a little bit of like background for me. I am a game designer, study game design at BIT, and I'm currently working on ACC. So what is creative coding? Creative coding is the use of a programming language as a medium to create visual or digital art, whether that's animations, visualizations, games, generative art, procedural art, etc., etc. It's quite a really big umbrella term that kind of encompasses a whole lot of stuff. And so I was first introduced to creative coding through my dislike for animation. And when I say dislike, I mean dislike in terms of actually doing animations. A little bit of a backstory for me is I studied game design, and one of my majors was animation. I've always been a very visual person, always loved animation. So when I got the chance to pick it as my major, I was like, yeah, this is great. It's going to be an amazing time. I'm going to learn cool things. Well, cut to me in second year having mental breakdowns at 3 in the morning because animation kind of sucks, in my opinion. So as I was doing animation and as I was learning coding and kind of developing my love and passion for coding, I realized that coding and animation can kind of intersect, which is really, really cool. And so that's where I first stumbled upon creative coding, where you can use code to create figures. So something like this can be turned into script, which I think is really cool. So if we take animation and coding, what do we get? Well, my first introduction to creative coding was procedural animation. So what is procedural animation? Procedural animation is creating animations through math algorithms, conditionals in real time. So you're not sitting there painstakingly drawing each frame manually, creating a keyframe here, a keyframe here, and then interpolating between those, which is great because that was my biggest gripe about animation is I found it incredibly tedious. So how do we procedurally animate? Well, let's start off with just like this. Let's start off with a circle. Right. When you first learn to animate, you kind of start off with a circle, and lots of tutorials will be like, animate a ball. So that's what I did. So here's my circle. And let's see, okay, what can I do with the circle? Because it doesn't look very interesting on the screen right now. It's kind of boring. It's just a circle. So what can I do? Well, let's try and make it move up and down. Question is, will it work? And that question is no. Okay, that's great. But give me 2 seconds, guys. I'm so sorry about that. No, okay. Well, in theory, it was going to show you a ball moving up and down, but for some reason, it's not. That's great. But that's cool. So picture a ball moving up and down. Just envision it in your brain, guys. You got this. So it doesn't look very interesting, not very fun, not very cute. So how do we make the ball look more interesting? Let's see if this will work. It might just be my file. Give me 2 seconds. It starts it again. Cool. So a ball moving up and down. And it looks a lot more interesting to what I would have shown you before. That's because we've added squash and stress to kind of give it more personality and, something more interesting to look at. It has more weight. So cool. We created a ball. It can move up and down. So boring. What else can we do? So then I kind of decided, well, let's stick with the sphere, with the ball. What can we create with ball? So we can create quite a few things. Like So we can create a liner board. Cool. We could connect them with specificity for. Okay, I think it's when it's refreshing. So sorry, I'm gonna have to every single time start it up again. There we go. We can connect it with lines. Wow. Oh my God. So from there, I'm kind of like, okay, cool. This can kind of be turned into possibly a snake if we make the rectangle thicker, but how do we make it move? And how do we make it move in an interesting way? And so the one concept that I came back to when I was studying animation is called, called a distance constraint. So a distance constraint looks at you have an anchor, you have another point that you want this point to follow this anchor. So then you decide, okay, well, I want it to be to say about this distance away from the point. Cool. And so if you constrain your second anchor through that circle, it creates quite a cool movement. Right. So that's cool. Then we can chain these together to create something more. So it's a chain of anchors being anchored to themselves. So I can visually show this to you. Let's just hope that it will actually work. Let's close it and then pull it out again. Cool. So we kind of have this. That's quite cool. Moves in quite a cool way. And one of the other parts of a distance constraint is also an angle constraint. So for example, when you're animating, you have angle constraints because certain parts cannot move past a certain angle. So like the arm, my arm can only move this much, like 180 degrees. It can't go through full 360 because my arm would break. So if you apply this to the chain as well, you can get this movement, which is quite cool. So what can we do with this movement? Well, if we take the chain and the spheres and make different spheres different sizes, we can create different, something like a worm, a snake, or a fish. So if we take that and actually apply it to our moving chain, you get a little snake that moves. And I did this all through code, which is really sick. I didn't have to point out, I didn't have to infiltrate and having a cry because why? I could just do this with very minimum code, which is really cool. But it's the same, okay, what else can I make with these similar concepts? So I saw another person create a fish. So I was like, okay, that's really cool. I want to try to do that. And what is really cool about this concept is that you can create as many creatures and things as you can if you just imagine the shape correctly. So there is elements, which is really cool. So this is my little fish. She's a little janky, but that's it, right? No animate, like no physically animating all through code, which is really sick. So from there, kind of was like, okay, cool. I can make kind of these creatures, I can make them move, but what is there more? Because like that's kind of like I'm bored now. I want to find something new. So what I found was processing, and processing is a Java tool that you can use to create really cool visuals or animations or visualizations of algorithms and patterns and etc. And what's really cool is there's also a JavaScript version of processing, which is called p5.js. So p5.js is, this is what I'm going to use for the next part of the demo. but there is a web browser version of it and an actual VS Code extension for it, which is really cool. And it's really, really easy to use, and you can use it really quickly and kind of get used to it and start making really cool pictures and visualization. So how p5.js works is either your two main functions. You have your setup and your draw. Your setup you use to kind of define your space. So create canvas. I'm going to create a canvas of this size. My angle mode will be degrees. My rect mode will be center, so everything will be in the center of the canvas, and my background will be black. With draw, it will now then draw a rectangle, as I said. So then let's do this. As you can see, this is my rectangle in my canvas, and it's following my map, which is really cool. Now, the one really cool thing about this is that draw happens every 30 times a second, maybe. See if we actually, no, okay. Let's just dispose of it and start it up again. Oh, draw will happen every 13 to 60 times a second. I'm not too sure the exact number, but you can see how p5.js works is that it basically draws over and over and over and over, right? And so you can see it's layering on top of each other. So if you use this concept of it's basically layering objects and images and visuals on top of each other, you can create really cool things. So let's move on to the thing. So one of the cool things that you can create and where I started was something like this, which uses sign as kind of a visualizer to create something like this. And it took like maybe 10 lines of code, which is really cool. And what I'm doing is I'm basically drawing 200 triangles, fitting them at different sizes and different rotations. And then I'm using sign to kind of manipulate the actual rotation of each rectangle. Then that essentially creates this really cool oscillating effect. And then the same with the colors. I'm doing pretty much the same with RGB for R. I'm taking it using sign to then create this gradient, and this is what you get. And this kind of took maybe 10 lines of code, which is really cool. So you can do things like this, or you can do patterns, create different types of patterns. So this is the one pattern that I started to create, basically drawing a whole bunch of rectangles on top of each other at different points, which is really cool. Cool, but this is all kind of like basics and what else can we do? Like surely we can do something more interesting. And we can. So when you look into processing and p5.js, you'll see something that is called a flow field. Now, it's everywhere. Flow fields are really, really cool. Flow fields are essentially spatial representations of forces. So if I show you, so this is my flow field, and I'm using solar noise to kind of manipulate and create noises in the flow field. But as you can see, that each kind of line is a representation of a force. And what we're going to do is then create a particle that then follows this force. And it creates quite a cool visual effect. I don't think you guys can see that very well in person. I'm really sorry, but on my screen it looks great. So if you want to see it afterwards, you can come ask me. But essentially, if you can see, there's little particles and they're following the flow field and they're moving, and it's quite cool. And so that was kind of my first introduction to okay, movement and how do we can use movement and particles within p5.js to create really cool visuals. And so my next step was then to create a visual for time mold. So time mold is essentially, how do I describe it? I guess it's like an organic mold, right? And it's pretty cool because it uses really cool to kind of look cool versus so it creates, as you can see. So I kind of use this as an inspiration to create something similar. But how do we do that? So we start off with the circle. The circle is a representation of the stuff, and it has a left, a front, and a right, and that's how it traverses. So it moves through the space, and it looks for a path. And if the path is overlapping with the left, it will turn towards the left. And so, okay, but what is the path? Well, the path is when it moves, it leaves a trail. So what we do is actually look at the pixel and look at the actual color data of that pixel and go, okay, is there color data in this pixel? How much? If there's more color data on the right side, we will move towards the right. And that's kind of how it creates a path and how it creates a path. So if I show you, you can create something really cool like this, which these are all little particles kind of finding their little way through all the different parts. And yeah, that's pretty much visual coding, creative coding. And I hope you guys enjoyed it. And I hope I might have inspired some of you guys to start actually using code to create some visual images. Thank you.